Hi students, welcome to my channel Sri Academy of Physics and this is Dr. Balaji Rambatla. Students, in this channel I would like to post physics videos of level Inter, BSc, BTech and MSc and some of core branch videos also. Please go through my channel for better understanding of subject in simple way and score maximum marks in academics. In my videos, I provide complete notes of the topic and explain in English and in my regional language Telugu for better understanding of the topic. For this, please subscribe my channel Sri Academy of Physics. Students, ఈ వీడియోలో నేను మీకు కన్జర్వేషన్ ఆఫ్ ఎనర్జీ ఆఫ్ ఫ్రీలీ ఫాలింగ్ బాడీ గురించి ఎక్స్ప్లెయిన్ చేస్తాను. ఇది ఇంటర్మీడియట్ ఫస్ట్ ఇయర్లో చాలా ఇంపార్టెంట్ క్వశ్చన్, ఎక్కువగా 8 మార్కులు అడుగుతూ ఉంటారు. టాపిక్లోకి వస్తే లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ ఇన్ కేస్ ఆఫ్ ఫ్రీలీ ఫాలింగ్ బాడీ. ఇది మన టాపిక్ నేము, లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ ఇన్ కేస్ ఆఫ్ ఫ్రీలీ ఫాలింగ్ బాడీ. So to solve this problem, we consider a ball, of mass m is dropped from a building at a height h. So this is the building and this is at a height h and a ball drops from building to floor. So our aim is to calculate the total energy at point A, the total energy at point B and the total energy at point C. In all cases, the total energy should be remains same. That is we want to show. So whenever the ball drops from top position to ground level, at every position the total energy should be remains constant. Then we can say that the energy is conserved. We know that the total energy is nothing but the summation of the kinetic energy and potential energy. So the total mechanical energy of the ball is capital E. Right. We know that total energy is equal to kinetic energy plus potential energy. Generally, the total energy you represent with capital E. Kinetic energy is nothing but K and potential energy you represented as U. So this is the expression for total energy. Right. Our aim is to calculate the total energy at point A, the total energy at point B, the total energy at point C. Right. So from this equation, A is at a height h from the ground and B is at a height small h from the ground and C is at ground. So h value is equal to 0. Right. So A comma B comma C are the points A comma B comma C are the points at height at height h comma small h and ground respectively. ఎందుకు ఇక్కడ నేను మీకు రాస్తున్నానంటే మీకు నోట్స్ కూడా ప్రొవైడ్ చేసేటట్లు ఉంటుంది అండ్ ఎక్స్ప్లెయిన్ చేసినట్లు ఉంటుంది అనే ఉద్దేశంతో నేను మీకు ఈ నోట్స్ కూడా ఇస్తున్నాను. నౌ వాట్ ఈజ్ అవర్ ఎయిమ్? నౌ we calculate the value of capital E. Capital E means total energy at each point. So at every point we want to calculate what is the total energy value. So every point the total energy it should be remains same. Then you can say that the energy is remains same at every point of the freely falling body. Okay, now one by one we calculate. First point, at point A, right? So at point A, what is the case? For example, this is the ground. అంటే ఎగ్జాంపుల్ ఈ బొమ్మలన్నీ వేయక్కర్లేదమ్మా, ఫస్ట్ డయాగ్రామ్ వేస్తే సరిపోతుంది. This is the ground and the ball is at a point A. So it is at a distance of h from the ground. Okay, it is at a distance of h from the ground. This is the top position. So at the top position the velocity value is equal to 0, right? When you throw the ball or from the freely falling ball, the velocity value at the initial velocity value it should be equal to 0. Okay, so at point A the velocity value is equal to 0. Now then what is the kinetic energy value? The kinetic energy of the ball, the kinetic energy of the ball, the kinetic energy of the ball is equal to formula 1 by 2 mv square, 1 by 2 mv square, but this value should be equal to 0, right? అదవుతుంది కదమ్మా. The potential energy of the ball, at point A, the potential energy of the ball at point A is equal to, what is the formula for potential energy? mg into h. Here h is nothing but capital H, right? Now what is the expression for total energy? Total energy capital E is equal to total energy capital E is equal to kinetic energy plus potential energy. So kinetic energy value 0, potential energy value mg into capital H. So it becomes mg into capital H. So at point A, what is the total energy value? mg into capital H, where g is the acceleration due to gravity. This is the total energy at point A. Now here we calculate the total energy at a point B. Now what is the total energy at point B? That is we want to calculate. You are getting the same answer, we know, right? Our aim is to calculate the potential energy at point B. Now so మళ్ళీ ఒకసారి డయాగ్రామ్ ఇస్తున్నా. So this is the ground, right? And this is the ball at point A, and this is the ball at point B. This is A, this is B. What is the distance of this from ground? H. What is this distance? Small h, right? So what is the distance between these two? That can be written as h minus h. Okay. Now, when the ball reaches the point B, the height of the ball from the ground is h. Now, what is the velocity of the ball when it reaches the point B? That is, we want to calculate. For that purpose, we take the equation v square minus u square is equal to 2as. So what is the initial velocity at here? Initial velocity is equal to 0. What is the acceleration value? This is acceleration downwards. So the acceleration due to gravity is plus g. So in this equation here at point B, u is equal to 0, a is equal to plus g, and s is equal to h minus h. Substitute these values in this equation 1. We get v square is equal to 2. What is the a value? G. And s value is nothing but h minus h. This is the expression for velocity square at a point B. Now what is the kinetic energy value? Kinetic energy of the ball. Kinetic energy of the ball is equal to formula 1 by 2 m v square, right? So this becomes 1 by 2 m. What is the v value? 2g into h minus h. These two cancel. So you are getting mg into h minus h. This is the expression for kinetic energy of the ball at a point B. Now what is the potential energy value? The ball B, which is at a height of small h from the ground. So the potential energy of the ball, at point B is equal to mg. What is the h value? Small h. Total energy capital E is equal to kinetic energy plus potential energy. So total energy at a point B, you can represent it as mg into h minus h plus mg into h. When you solve this, we get mg into capital H. So here also the total energy value, the total energy of the ball at a point B, we can represent it as mg into capital H. Now, last case. At a point C, what is the case? At point C, what is the case? So here the ball is at ground. At point C, the ball is at ground. This point is C. So here, what is the value of H? 0. What is the value of H? 0. And what is this is the point of A. This is the point of A. And this distance is called capital H. initial velocity u is equal to 0. This is called S. And a value is equal to plus g. Okay. And what is the velocity of this ball at this position? That is you want to calculate. So when the ball reaches the ground, what is its velocity? That is you want to calculate to measure the kinetic energy value. So for this purpose, again you are using the formula v square minus u square is equal to 2as. But what is the value of u? 0. What is the s value? S is equal to capital H. And what is the a value? Plus g. Now this equation becomes v square is equal to 2g into h. 2g into capital H. This is the formula for the velocity square. Now here we calculate kinetic energy. Kinetic energy of the ball. Kinetic energy of the ball at point C. Kinetic energy of the ball at point C is equal to what is the formula? 1 by 2 mv square. So this is equal to 1 by 2 m. What is the v square value? 2g into h. These two cancel. You are getting mg into capital H. Okay. Potential energy of ball. Potential energy of the ball is equal to mg into what is the h value? 0. So here the potential energy becomes 0. Therefore, the total mechanical energy of the ball at C is total energy is equal to kinetic energy plus potential energy. So this value is again, what is the kinetic energy value? mgh. What is the potential energy value? 0. So we get this value is equal to mg into h. Okay. So from this equation, it is clear that at point A, the kinetic energy value is equal to 0. At point A, the kinetic energy value becomes 0 and the potential energy is maximum. At ground level, the kinetic energy value is equal to maximum and the potential energy value should be equal to 0. Right. So when the ball which is falls from point A to point C, at this point, the potential energy value is maximum and the kinetic energy value is equal to 0. When come to point C, the potential energy value is equal to 0 and the kinetic energy value is maximum. Okay. So in this manner, a ball which is travel from point A to point C, there is a change in kinetic energy and potential energy values, but the total energy value is always remains constant. That value is equal to mgh. This concept is called conservation of energy. The energy not created nor destroyed, which is transferred from one form to another form. Here the potential energy converted to kinetic energy. Okay, thank you. Thank you for watching this video, and for more useful videos, like, share and subscribe my channel Sri Academy of Physics.